How does artificial intelligence actually work? You may have used ChatGPT to write an email, asked your phone for directions, watched a movie recommended by Netflix, or unlock your phone with your face. These tools can feel almost magical. But behind the scenes, artificial intelligence is not magic, and it is not a machine that thinks exactly like a human being. AI works by finding patterns in huge amounts of data, learning from examples, and using what it learned to make predictions, generate content, or help make decisions. In this video, we'll explain how artificial intelligence works in a simple, beginner-friendly way.
Let's begin with a simple definition. Artificial intelligence, or AI, is a broad term for computer systems that can perform tasks we usually associate with human intelligence. That includes recognizing images, understanding language, translating text, recommending products, detecting fraud, playing games, and creating images or music. But AI is not one single technology. It is an umbrella term. Under that umbrella, there are many different approaches. The most common approach today is called machine learning. Traditional computer programs follow explicit rules written by people. For example, if the temperature is below 0, show a snowflake icon. The programmer defines the rule first. Machine learning is different. Instead of writing every rule manually, developers give the computer many examples. The system uses those examples to discover useful patterns for itself. For example, instead of writing thousands of rules describing every possible cat, you could show an AI system millions of labeled images, cat and not cat. Over time, the system learns visual patterns that often appear in cat photos.
The first major ingredient in AI is data. Data can be text, images, audio, video, numbers, sensor readings, customer purchases, medical scans, or almost anything else that can be stored digitally. Data is the experience AI learns from. Imagine teaching a child the difference between apples and oranges. You do not explain every tiny detail using a long list of rules. Instead, you show examples. This is an apple. This is an orange. After seeing enough examples, the child begins to recognize the difference. AI learns in a similar way, but at a much larger scale. The quality of the data matters enormously. If data is incomplete, inaccurate, unbalanced, or biased, the AI can learn those same problems. An AI trained mostly on one type of face, language, accent, or situation may perform less accurately for others. That is why responsible AI development includes cleaning data, checking for bias, protecting privacy, and testing systems carefully before they are used in the real world.
Now let's look at machine learning more closely. In a basic machine learning task, a model receives input data and tries to produce a useful output. For example, the input might be information about a house, its size, location, number of rooms, and age. The output could be an estimated price. During training, the model sees many examples where the correct answer is already known. It makes a prediction, compares that prediction with the correct answer, measures how wrong it was, and adjusts itself slightly. Then it repeats the process again and again, often millions or billions of times. This is called supervised learning because the training examples include labels or correct answers. There are other types as well. In unsupervised learning, the AI looks for hidden patterns in data without being told the correct answer. For instance, it may group customers with similar buying habits. In reinforcement learning, an AI learns through rewards and penalties. Think of teaching a dog a trick. Behavior that gets rewarded becomes more likely. This method has helped AI systems learn to play complex games and optimize certain decisions. Many powerful modern AI systems use something called a neural network. A neural network is loosely inspired by the way networks of neurons work in the brain. But it is important not to take that comparison too literally. Artificial neural networks are mathematical systems, not digital brains. A neural network contains layers of small calculation units, often called artificial neurons. Each unit receives numbers, performs a calculation, and passes a result to the next layer. Let's return to the cat image example. The early layers may learn simple visual features, such as edges, colors, or textures. Later layers can combine those features into more complex patterns, such as ears, eyes, whiskers, or the shape of a face. Eventually, the network produces a result, perhaps a probability that the image contains a cat. The values that control these connections are called parameters, or weights. Training means adjusting huge numbers of these weights, so the model becomes better at its task. When a neural network has many layers and very large numbers of parameters, it is often called deep learning. Deep learning is a major reason AI has improved so quickly in image recognition, speech recognition, translation, and generative AI.
If this explanation is helping you understand how AI works, please take a second to like this video and subscribe to the channel. It really helps the channel reach more people who want clear, practical explanations of artificial intelligence, technology, and the future. And stay until the end, because we're about to explain how tools like ChatGPT generate answers. Generative AI is AI that can create new content, including text, images, audio, video, and computer code. ChatGPT and similar tools are based on a type of AI called a large language model, or LLM. These models are trained on extremely large collections of text. During training, they repeatedly practice a surprisingly simple task, predicting the next piece of text. For example, given the phrase, "the capital of France is," the likely next word is Paris. By making this kind of prediction over and over across enormous amounts of text, the model learns patterns in grammar, facts, writing styles, reasoning-like structures, and relationships between ideas. When you type a prompt, the language model does not search its memory in the same way a person recalls a fact. Instead, it calculates which next token, a word or piece of a word, is most likely to be useful based on the prompt and the text already generated. It then predicts the next token, then the next, and continues until it creates an answer. That may sound simple, but at scale it becomes incredibly powerful. Modern large language models use an architecture called a transformer. Transformers are especially good at looking at relationships between words in a sentence or across a long passage of text. This helps the system understand that the meaning of a word depends on context. Still, a language model is not automatically a perfect source of truth. It can make mistakes, misunderstand a question, reflect biases found in training data, or confidently generate incorrect information. This is often called an AI hallucination. For important topics such as health, law, finance, or safety, always verify AI-generated information with reliable sources or qualified professionals. After training comes inference. Inference is when the trained AI uses what it learned to process new information. Suppose an AI has been trained to identify spam emails. When a new email arrives, the AI converts features of that email into numbers. It may consider the wording, links, sender behavior, formatting, and other signals. Then the model calculates a probability. Is this message likely to be spam or not? The AI is not thinking in the human sense. It is processing information through mathematical patterns learned during training. The same core process appears in many AI applications. A recommendation system predicts what you might want to watch. A navigation app predicts travel time. A voice assistant predicts the words you said. An image generator predicts what pixels may match your text prompt. Different tools have different designs, but pattern recognition and prediction are at the heart of much of today's artificial intelligence. Understanding how AI works also means understanding what it cannot do reliably. AI does not have human emotions, personal experiences, common sense in the full human sense, or moral judgment. It does not automatically know whether something is true, fair, safe, or appropriate. Those qualities require human oversight, clear rules, and responsible design. AI systems can also inherit bias from their data. They can expose private information if handled carelessly, and they can be misused to create misinformation, scams, deepfakes, or unfair automated decisions. That does not mean AI is inherently good or bad. Like many powerful technologies, its impact depends on how people build it, govern it, and use it. The best approach is not blind excitement or blind fear. It is AI literacy, understanding the technology well enough to use it thoughtfully, ask good questions, and recognize its limitations.
So how does artificial intelligence work? In simple terms, AI learns patterns from data. Machine learning improves through examples. Neural networks use layers of mathematical calculations to identify complex relationships. And generative AI, including large language models, creates new content by predicting what should come next. AI can be remarkably useful, but it is not magic and it is not a replacement for human judgment. The more we understand how AI works, the better prepared we are to use it responsibly. If you enjoyed this AI Explained for Beginners video, like it, subscribe to the channel, and comment below. What AI tool do you use the most? Or what part of artificial intelligence would you like me to explain next? Thanks for watching, and I'll see you in the next video.